All right, welcome to class today. So, under the courses for this class now, I'll try to get this filled out. Second, technical difficulties. You guys see it down on the coast?
Yeah, we got a screen.
I don't see it here. Sorry.
See it down here.
Looks like it should be. Oh, there we go. All right. So, I've updated the Canvas page. These will be basically where you turn stuff in. Last week I said technically you don't have to turn anything in for the first lab, so the 0 points reflects that. If you want to turn something in, you can. Today and next week and every subsequent week, there'll be something to turn in. So turn that in here in Canvas. However, as I mentioned before, almost everything else for this course will be distributed here on the page. So there is a desktop app that you can use for GitHub if you like. It's not required. You can just download everything like we said before. I have a bunch of other projects, like real projects, that I'm working on. But if I wanted to get the contents of a repository that exists online, I can go put that in. I can clone it. So I can look for this repository. You guys can't do that because if you did, then you would be modifying my code. So what you can do, if you wanted to do it this way, is go and what they call fork it. There's a button at the top right of GitHub, and you can fork it. You don't need to do that, but you can create your own version of my course, and then you can upload things. This isn't really necessary unless you're planning to both add and take away from change a repository. You guys aren't changing the repository, so you don't need to do this. I'm going to clone spatial programming to the spatial programming course to my drive here so that I can change things and then post those changes. So I'm going to put it in C temp. Say okay. Oh. Looks like, bear with me for a second. C temp SPA. I'm going to call this SPA old. And then just redo it. Clone. Alternative to what I've just done, you can do what I mentioned last week. You just download it. Now I'll be updating things week by week. So you might just want to download each week. See what I put. C temp. So now it's going to copy everything down into that directory. So we're on week 2, which is right here. On week 2, we're going to be learning about functions. Okay? And a few other topics. So let's review a little bit from last week. So last week we talked about variables, operators, data types, and functions. So let's start with data types. Okay? So somebody give me an example of a data type. Boolean is a data type. Good. Anybody else? Some other integer? Integer, yep. String. Those are all examples of data types. Exactly. All right. So from there, from the data type, float was one that wasn't mentioned, but it's a data type. From there, what's an example of a variable?
Variables when you assign values,
Right. Yep. You give a label to an instance of a particular data type. So you could set you could set x equal to 5. I started to say it wrong. So x is the variable, and you're setting it equal to 5. So in Python, you would write x equals 5 to do that, to get a variable. You could set x equal to true. You could set x equal to 15.2, which would mean that it's a float. And you could set x equal to George, which is a string. So those are all examples of variables. Now, operators are just your typical mathematical operators. And if we combine variables and operators into the same, to form a sentence that Python can interpret, that's called a statement. Probably should have had statements up there too. Okay? So we talked about all those things last week. So if I bring up the Python interpreter. Okay, so if I said x equals 5, I'm setting x equals 5. That is a statement. But if I said x divided by 5, the answer is 1, that's also a statement. Those are both statements. There's some simple math involved in that. Now, we talked about a few functions, but all the functions we talked about last week were functions that are built into Python, that already exist inside of Python. We talked about the type function, where we can ask a variable what type of data type is inside of it. We talked about the functions that are inside of math, where we could do math.sqrt x, and it's going to give us a number. So that's a function. Those are both functions. Today we're going to talk about making our own functions. I did put on here that we're going to talk about the modulus operator, or sometimes it's just called the mod operator. We actually did talk about that last week. It's the one where if we do integer division, it returns the remainder rather than the quotient. Okay, so the remainder after integer division is what modulus turns in. The reason why that sometimes gets used in computer science is that sometimes you want to repeatedly loop through a set of numbers. Like, let's say we wanted to loop through the numbers 1 to 12 multiple times. We wanted to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we wanted to go 1, 2, 3, 4, 5, 6, 7, 8, number 11, 12. We wanted to do that a number of times. Why would we want to do that, first of all? Yeah, it saves us from doing it manually. But in my particular instance, for example, there are 12 months in a year. So looping through the months would allow us to loop through multiple years. Like if we're trying to model something that's years and years. Instead of looping 1 to 48, we can loop through 1 through 12 a number of times. We can do that with the modulus operator. We'll talk about how later, once we start talking about looping. All right, so now we're going to talk a little bit about logical operators that are useful in computer science. So we've talked about logical operators in other GIS classes, so this might be a little bit of a review. But let's first review a Boolean expression. So if we want to find out if x is equal to 5, then we say x equals 5. All right? We use a double equal. That's a comparison. And we're querying to see if x is equal to 5. Right? So one example of a Boolean operator is, a logical operator is we could combine two or more Boolean operations, and we can say, is either one of these two conditions true? Okay, that's called an OR operation. We combine two expressions that can both evaluate to true or false. That's an OR operation. So if I also had a y equal to 6, let's say, I could say x equal 5 and y, or sorry, I'm doing OR first, or y equals 7. All right? Now, with the OR in there, what happens is, if either of these two things is true, if x is equal to 5 or y is equal to 5, I'm going to get a true. So, is it going to be true in this case? Yes, because x is equal to 5. Y is not equal to 6, but x is equal to 5. So that's true, whereas this is false. Okay? Now if I change that expression, we're going to talk about our next one, which is and. If I change it to and, then it's false. Because with and, if either expression is true, then it will be true. If either expression is false, then it will be false. Both expressions have to be true in order for it to be true. And we can chain together as many tests as we want. So these form the foundations of logic. And sometimes you're going to have to do logic in your program. Like if you want your program to, let's try to think of a GIS example. If you want your program to calculate let's say you have a particular value that represents no data. But if the value doesn't represent no data, maybe it's negative 99. So if you want the value to, if you want to test for 99, you could say, if the value equals 99, do something. And if it doesn't equal 99, do something else. Okay, so these are what we're saying form the foundation of questions, foundation of logic. So or, and there's a few others, but probably one of the ones that's a little bit more useful is this one. So that's not. Not just takes a Boolean expression and returns the opposite, whatever it wasn't. So not x equals 5 returns false. Because x does equal 5. Now, we may or may not use this that much, but numbers are always evaluated as if they are Boolean. So if I said not 1, it's going to return false. Any non-zero value is treated logically as a true value. Any non-zero value is treated as a true value. So if I say not 0, 0 is false, then it returns a true. So that's just something that's interesting. I think it's better to use actual Boolean values. But it might be shorter for you to write something. If you're just trying to check to see if something is 0 or not, you could just use the name of the variable and see if it's 0 just by saying is it equal, is it false? Is no data treated as false?
Like,
So Python,
will like find out if the -99 is treated as no data or not.
Python does have the concept of a no data, and it's a data type that's called NaN. Oops, N-A-N. Nope, I guess not. Maybe if I put it in quotes. No. I forget how to create it. It like, sometimes you'll see later that when it reads data from GIS, if there is a no data, it'll turn it into a NaN. I don't know, but I don't know how to create one. Okay, so if you float it, it looks like yeah, so if you went like that, float, man, you would print NaN. That's a type of, let's see what the data type is. It's a float, so it's a type of float, and it stands for not a number. It's no data. There's also another special number called infinity, INF, that you can set values to if they're the float data type. All right. I didn't know how to create those numbers. Usually you don't create them; they just show up in your work when you're doing it. Okay. So we did that. Now, one of the reasons why these are useful is for what we call branching, and later we'll talk about looping. Let's talk about branching today. Okay? For this, I'm going to start writing some programs. So I'm going to remember the way to write programs is you take the Python shell and you create a new file. So I got my new file here, and I'm going to write. I'm going to save this program out already. Save as. I'm going to save it into the folder so that we'll have some examples. So I'm going to save it in C, temp, SPA, week 2. I know this is getting. So I'm just going to call this example 2018-1 and save it right there. Okay. All right. So we're going to use a logical operator in a program. Logical operator to test for something. So we're just going to create two variables called x equals 5, y equals 7, and we'll say if, oh, we forgot to do, I'll show it in the program. So an if statement is branching. So branching in computer science is the process of saying, testing a condition, and if a condition is true, executing some code. Optionally, we can test the condition, and if it's true, execute some code, and if it's false, we can execute a different set of code. So we're testing a condition and executing either only on true or false. So I'll show both of those examples. And I forgot to mention the greater than, less than, when I was talking about logical. And those are really important, so we'll talk about it now. So I'm going to say if x is greater than y, I'm going to say print x is bigger. And just so that the program runs, I'm going to print done at the bottom, just so we know that it's done. So in Python, I'm just going to give you a few syntax pointers here. In Python, this isn't the same in every computer programming language. All computer programming languages have this construct of a branch, created usually by an if statement. But the way it's constructed is different in different languages. In Python, the way it's constructed is that after your statement, you put a colon. After your condition. If, and then the condition, and then a colon. The colon is the way that it starts doing a block, what we call the code block. And it's going to execute the code block if this condition is true. The other unique thing about Python here is that this spacing actually matters. So if you're not programming in IDLE, if you're programming just in a text editor, did you all see that when you pressed enter, or when I pressed enter, it indented automatically for you? Okay? All right? That indentation is important. Without that indentation, it wouldn't work. In fact, I'll show you. I'll try to run this. And if I try to run it, it's giving me an error. It's expecting an indentation block. What type of error is that, by the way? Syntax error, exactly. It's not a runtime error. It wasn't even able to compile it. So it needs that.
Dr. Draper.
It's a colon.
Thank you.
Yep. The other thing is, notice how many. I have 1, 2, 3, 4 spaces. That isn't important. Okay. Well, it puts the 4 spaces in there for you in IDLE, but as long as you are consistent, the number of spaces, or even tabs, you can use tabs instead of spaces, doesn't matter. The bad thing about using tabs is if you start using tabs, you might confuse them for spaces and put spaces in next time, and they look like they're exactly lined up. Maybe you don't know what I'm talking about. But let's say I went down here, I pressed enter, and I pressed back for some reason, and then I pressed the tab button. So this, well, okay. IDLE isn't allowing me to actually put a tab character in there. So it's being smart and helping me out. But if I was using Notepad or whatnot, see how these are all spaces? If I was using Notepad, and this, I've had these periods time before, like, let's say I write a Python script and it's up on a server and it's running a website for me. So I open it up on the server and it doesn't have IDLE installed. So I open it up and I change it in WordPad and I press tab instead of space. It can happen. So they have to be the same number and the same type of characters. And it has to be white space characters. So only spaces in tab work. All right. So that's how you tell it that it's going to run. I mean, that it's going to run this code block. Now, the code block is over when you unindent. Once you unindent, this code block is over. It's not based on the condition anymore. So when we start to execute this, it will evaluate this statement, and if it's true, it will execute this. But it will then execute this line no matter what. That line gets executed because it's back outside of the indent. It's not inside the code block anymore. Right? So now when I run this, when I run that module, all I see is done. That's the only thing that happens is it says done on the page. Why didn't it say X is bigger? Well, the smart aleck answer would be that X wasn't bigger, right? Right, but why in the computer? A little bit more detail. Why didn't this run?
Evaluated the false.
Yeah, the condition wasn't true, and it only will run this condition if it's true. Does that make sense? If that's true, it'll run it. So we could make it true in a few ways. We could change the condition, okay, and it would actually run. But what's wrong with this? Now it says X is bigger. The condition's true. But what's wrong with our code? It's not a syntax error. It's not even a runtime error. It actually ran. It's the third type of error we talked about last week. Yeah. So you can call it, the book had a word for it, but it's a logical error, right? Because this shouldn't run when this is true because it says x is bigger. Is x bigger? We didn't make x bigger, did we? No, we just flipped around the sign, and so this evaluates as true, but this label is attached and runs. So it prints x is bigger, even though it's not. We made a logical error. All right? So, how could we change our code so that the original thing was better? It's pretty simple, right? How can we change this code so that x is in fact bigger than y?
Make X 8.
Yeah, exactly. We can make x 8. Or any number that's bigger than 7. So now when we run it, it's going to produce the exact same results. And x is bigger, so that's true. And we've got that run. Okay. We do have greater than or equal to, just so you know. So now, the only problem is if we make this 7 and we try to run it, now it's going to say, and we still have a logical error. Okay? X isn't bigger, it's just equal to. So we'd have to change x is bigger or equal to. So let's go back to the previous suggestion. All right. So now x is bigger. All right. So that is an example of a very simple branch in our program. It's not a very big branch. It's just a little branch. What if we wanted to create 2 branches? In other words, we wanted to say if it's true, do this. If it's false, do this. On Python, you type in else. And then you put a colon. You have to put a colon. And then write print y is smaller or equal. Like that.
Wouldn't that be bigger?
Oh yeah, sorry. Exactly. Y is bigger or equal. All right. So now if I run this, I'm going to get the same answer because it's not going to execute. It's only going to execute this. It's not going to execute this because it's either going to one branch or to the other, but not to both. Okay. So I could change this back to 5, and I would get y is bigger or equal. Well, let's test to make sure that works. Put 7s on both. So I'm going to run it, and I get y is bigger or equal. Okay. What if I wanted to test? What if I wanted to do that? Figure out if it was bigger, if it was greater, or if it was equal. Okay. Well, then I have to nest a third if statement in there. There's a few different ways to do this. One is to continue. So if they're equal, that falls in this part, right? Like this is the code block that represents if they're equal or y is bigger. This is code block. Everybody agree with that? So I could put another if statement right inside of here that just tested whether or not it was equal, like this. If x equals y, then say print they are equal. And then I could just leave the statement here, print, no I couldn't, because if I just leave it there I have to go else. Print y is bigger. See how that's one option? Let's just follow through the program here. Just a second. I did this last time I taught the course, but it was a long time ago, so I just remembered until now. There was a way. There was a way to set the size, because it helps the guys on the coast a little bit. Oh yeah. That's the way you set the white space. Courier size, let's go up to 12. It'll make it a little bit easier to see.
Oh, thank you.
There.
All right. So it's a little bit easier to see now.
Dr. Rager,
Yeah.
do you mean to get rid of that L statement, print Y is bigger than equals?
Yep. Well, let's see. That's what I was just about to do, is test my logic here. So if x is greater than y, it's going to do that. So that's true. Else, any other condition, it's going to test. First, it's going to test if x is equal to y. If they are, it's going to print equal. If not, it's going to print y is bigger. So right now, it should print they are equal. And it does. And if I change this to 8, it's going to say x is bigger. And if I, if I change this to back to 5, it's going to say y is bigger. So they all work. Okay. So that's one way. There actually is a few other ways to do this, including one that we haven't covered yet. I'm gonna go ahead and now save this as 2 and show you another way that it would be valid. .pi. There is a way to shorthand this and write else if. So this would only be slightly shorter, but you don't have to put the second if on the second line. So this is going to work the same way, and we can even indent these guys. So now what it's doing is saying, if this is true, do this. Else, if this is true, do this. Finally, all other conditions, do this. All right, so I'm going to run that, and I'm going to get the same result.
Hey, Dr. Ray.
Yeah.
If you didn't change the indents on those prints and they were still off to the right, it would crash?
No, it wouldn't. So it's actually LF. So the shorthand is LF. Sorry. No, actually it wouldn't. We could take these indents back out, and it's not pretty code, but it'll still work. And the reason is that only everything inside of the code block needs to stay consistent. So you can have as many spaces as you want, but everything in that code block has to stay consistent. And everything basically after the colons is considered within the code block. So if I did on the next line, if I said print, isn't that awesome? But I indented that differently, then I'm going to get an error. That's what I meant by you had to be consistent.
Oh, okay. And do you need the colon that's on the second else?
Yes, you do.
Because but you don't need it for the if or the else.
You do. It's right here. It's after the condition. Same with the if.
Oh, I got it.
You always need so the else is kind of like, you can put a space here if you wanted to. the else is kind of like there's a condition. It's kind of like there's a condition, but that condition is everything is true. Everything else. Okay? All right.
Right.
So you can have as
Right.
many of these else if statements as you want. You can actually leave off the else. But if you leave off the else, nothing will run if none of the statements are true. If you have an else, it's a catch-all that says, even if none of the other statements are true, then run this code. But if you don't have an else without a condition, then that's not necessarily true. We could take out this thing right here, and it would be a valid Python program, but it would never run if y was bigger. Well, it would never run any of the code block. See how it just says done? I'm gonna edit undo. Oops. I'm actually. Now you ask if we could do this, and I said yes. I just don't think it's pretty. I think you should stay consistent. So that's the way I would write it, like that. So now if they equal 7, it runs. Okay, they're equal. Isn't that awesome? Done. Okay. Now, there are some computer programming languages that have a construct called select case or case that'll work similar. Python doesn't have that, so you have to use else if. And they shortened else if to LF, which is technically the same number of characters as with case. So, all right. But case, well, you can use case to say. Basically, select on a variable to equals this, do this, 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 this. It's the same thing there. Okay. All right. Look at my outline here. So we covered branching. We'll cover looping here in a bit. We talked about conditionals. This is your condition here. We talked about logical operators. So this is referred to sometimes as conditional execution. This code is executing when this condition is true. Okay. The difference between conditional execution and alternative execution is that you have an else statement in there. That makes it alternative. In other words, there's something that will run no matter if all of the other variables are false. In fact, it will only run if all of the conditions in the nested if statements are not true. That's the difference between y is bigger and done. Done runs no matter what. Y is bigger runs if and only if all the other conditions above it in the same nested line are false. This code here runs no matter what. So this is like going back to the main program. All right, that's the difference between conditional and alternative execution. You can nest. We did. So in this example, this is what we would call nested, because this if statement is nested inside of this if statement. You could have as many deep layers of if statements as you wanted to or needed to create the logical explanation or the logical path that you needed to follow for your program. So if your path needed a bunch of if statements, up to 5 levels, 10, 15, however many you needed, it could have them. You can nest if statements, although you often don't need to go that deep. Yeah?
That LF. So you were saying that's a shortcut to the if, else, just instead of doing if, else, then another if, we just do LF all the way down and that's it?
Exactly. Yep.
Okay.
Yes. Now, the difference here is, though, if you do an elif, it's on the same level as the if. Whereas if you said else if, the if would need to go in one level, like it did in this file. See how the if was then indented?
Yes, sir.
Okay, run is the same, right? That's just.
Yes. The logic that it creates in those two examples is the same. But like, for example, if I said if x equals 7, so now this will run. But that'll only run if they're both 7s. Why? Well, it's because it's inside of the else statement that they're equal. So I don't have to test y and x. I already tested if they were equal. This statement will only run if this is true and then this is true. So it's a nested statement. I've already checked that's true. Now I'm checking something else is true.
So should it have printed?
Yeah. Yeah, exactly.
Okay.
Remember in the script it'll only print if you explicitly tell it to print. So yeah, it did print. Good call. All right. Okay, so now we're going to talk a little bit about writing our own functions. That's the next kind of concept that's important. Okay. That was example 1. I'm going to close that one up for now. Here's example 2. I'm going to now save this as example 3. And we're going to change it up. Let me try to do this right. 3. Okay, so now this is example 3. A function is a set of code that you can call and run multiple times. You set it aside as its own piece of code. So for example, all of this stuff that we just did, we could turn that into a function. And then we could use that to test any two pair of numbers over and over and over. And we wouldn't have to rewrite all that code that we just wrote. So it'd be useful because functions are really cool because we don't have to rewrite code that's common. Anything that we do more than once in our program, we can do it. That's one good reason for functions. Another good reason for functions is that we can write a function that does a fairly simple task and then run it one time with some simple operations and see if it works, and then we can feed it more complex operations after that point. So compartmentalizing our code is another reason that functions are so valuable and help. They basically help us write more organized code. So I'm going to turn this into a function. One thing I'm going to do here is it's good to put our functions up at the top. I'm just going to remember to keep done here at the bottom because that way we just know that it finished. All right. If I want to create a function, what I have to do is type in the word def. Def means define. I'm defining a function. Then I have to give my function a name. I'm going to call my function something really long. It's going to be called which is bigger. You can give your functions whatever names you want. And then, whenever you create a function, you have to have a parenthesis and a closing parenthesis. We'll talk a little bit more about what goes in there in a second. So I've got my def, which is bigger, and I have a parenthesis and a closing parenthesis and an equal sign. All right? Okay. The next thing that I need to do is, like branching, I need to take that code block and put it all, indent it all, so that it's all under which is bigger. So now I'm going to take all of this code and go under Format and just hit Indent Region. Format, Indent Region. And what that does is it takes all of this code, make sure you don't put the print done down here, all the code, and it indents it over. Okay? Now I have a function definition, and I have this is the body of the function. This code block represents the body of the function. And anything outside of the body isn't part of the function. So what it's going to do is it's going to read this line and interpret it. Nothing to do except for create a value of 7 in memory. It's going to create a value of 7 and in another place in memory and call that y. Then what it's going to do here is actually create this function. And finally it's going to print done. So if I run this, all it does is print done. It doesn't actually do anything with x and y. It didn't actually do any of that. Okay, the reason is because that function just got created. In Python and lots of other programming languages, functions are just another data type. So this is a function, and I can actually prove that by saying type which is bigger, and it's going to tell me that it's a function. Oh, I need to print it. So it tells me that that's something that's a data type function. Okay? Now that's not really useful, but if we actually wanted it to run this code, we have to call it by saying the name of the function, and then we have to put the same parentheses here in order to call it. So what that does, now when we have this word here, it calls it. It says, okay, this is the name of the function. It calls it and it executes the values there. So I could hit run module, and now it looks just like it did before. Okay? Now, so far, it's not that cool. There's no real reason that you might think, well, why would I ever do that? You might think that. We could run it lots of times without retyping all the code. All right, and sometimes that's important, but sometimes it's not. Okay. What really is helpful is that when we create things inside of our function and we pass variables into a function. What's a mathematical function like? If I said y equals mx plus b, and I said that y is 7, and x is, so m is always going to be, let's say, 0.5. Then I could give a bunch of x values, and it would tell us what y is going to be, right? That's what a function is. In computer science, functions can take inputs, and those inputs are called parameters. And we can, or sometimes arguments. Arguments are parameters. So we can feed in as many arguments as we want into a function, really. Okay? So let's feed in two arguments, A and B. Actually, let's just call them X and Y. This will actually, it might be confusing for a second, but it'll actually teach a concept by calling it. So x and y are now parameters that we feed in. If we create these arguments or parameters, we need to feed them in here. So let's feed in values. Let's feed in 5 and 7. The order matters. So 5 is going to be x and 7 is going to be y. And we'll run it and see what happens. Okay, it says y is bigger. Now, the reason that I just kind of paused and thought for a second, maybe we should call it A and B, okay, is related to this. Y is bigger. That makes sense because 7 is bigger than 5, right? But up here we set x equal to 7, but down here x is equal to 5. And watch this. This might be even more confusing. Print x. What do you think it's going to be? It's going to be 7. All right, good. So some people have read. Why is x 7? For those of you who knew the right answer. Yes, only inside of this function. So in computer science, this is referred to as local variables versus global variables. So it's kind of like what happens in Vegas stays in Vegas. So what happens inside the function stays in the function, right? This x only exists inside this function. As soon as this function ends, this x and this y don't exist anymore. Now we'll talk about an exception in next week, but before we get too confused about that, so if we pass in x and y, they don't change. Now if we did put x and y here, that doesn't change anything. Like now they're both going to be 7, but they're still passed into the function as 7 and 7, not x and y. Okay? This x is different in memory than that x. So it creates a copy, a new 7 and 7, puts them in the function runs, and we get answers, and x is still... The way we can prove that is that we could actually, inside the function, set x equal to 6. So now if I try to run this, you'll see that x is still equal to 7. Right here, this print statement that printed out x still says it's 7, even though I changed the value to 6 inside the function. So it's a totally different variable. Even though we named it the same thing, they're different variables. So you have to watch out for that. These are local variables, these are global variables.
And those are parameters then, right? So x and y inside
Yes.
is bigger. Those are parameters.
Yes, or arguments. Sometimes different literature calls them different things. So arguments or parameters are local.
Those are both the same. Those are both terms the same.
Yes. Arguments and parameters are a term for the same thing, and they... Now, if you want to get a number out of a function, you can do that. The book calls those fruitful functions. Fruitful functions will return something out of them. A logical thing for us to return out of this function would be the larger number, because we're asking which is bigger, right? So if x is bigger, we could say return x. If y is bigger, we could say return y. And then if they're not, we could say just return x, because if they're the same, it doesn't really matter if we return x or y. We're returning the bigger number, which is the same number. So we put these return statements in here, and the return statements will come out of the function, but they need to be set equal to the function. I'm going to go ahead and save this as, before I run it, I'm going to save it as example 4 because it kind of introduces a new concept here. So now we have a function called which is bigger. It takes two numbers, and it takes those two numbers, and the bigger number gets returned. And we can just write print bigger in the word bigger. So whatever is the biggest number now gets returned. So we can run this again. And of course 7 is going to get, so let's change this to 20. And now you can see 20, it says y is bigger, 7. 20 is printed when we print the bigger number. It's always going to be the bigger number no matter which number is bigger. So if we change this to 40, it's going to return 40. See how it just returned, X is 40 now, and it also returned 40 because that's the bigger number. So we just wrote a function to find the biggest number and also print which one's bigger, and then it actually returns the bigger number. So probably, like if we were actually writing a real program, all these print statements that are inside of the function, those would just be for testing purposes, and we take them all out. So we have a function. In fact, we could do that as example number 5.
Craig, I have a quick question on
Yeah.
the return statement. Are you limited to how many returns you can do in one function? I think the other languages can only do one return.
Yes, you are limited. So here I'm going to delete all these extra print statements. You are limited. You can only return one thing. Okay? Now today, we've only learned about data types that are one thing. We've only learned about data types that are floats or strings or booleans, right? But they're actually data types that are composites of multiple things. They could be a list of numbers. Okay? So you could write a function that takes in a list of numbers and finds the mean and the standard deviation and the min and the max and returns that as a list of numbers. So the question was, can you return only one thing? The answer is yes, but the thing can be a multiple faceted entity, which we're going to call an object in this class. The thing can be an object that you could return to outside of the function. You can return an object, and we'll get into that next week. All right? Because we're going to talk about those types of things. In fact, we already know about one of them. A string, if you think about it, is really a multifaceted thing. Okay, it has multiple characters associated with it. So when if you return a string from a function, you're returning a bunch of characters. Well, we could do the same thing with numbers. We could return a series of numbers. And I don't just mean a big number. I mean multiple numbers that are together. All right. 15, 12, 18, 7. We could return a bunch of numbers. Like the example I said. So return X, and return Y. So I changed it. So now I'm just cleaning this up a little bit. I'm going to take this out too. So now when I run this, it's always going to just print the larger number for me. It's going to figure out what the larger number is and print it. I could even do that a little bit more and change up these numbers. 30, 12, 18, 16. Just to simplify this, I'm going to put the print statements beforehand. So now I've run that 3 times, and I've got a function that's always going to return. Oh, I can't put a print statement, and, well, I could just go like this, take out the word bigger. That'll work. So I'm not creating a variable, but you understand that it's coming into a new variable. And when I run that, it prints it. So it prints out 40, 30, and 18, because at first 40 was the biggest, 30 was the biggest, 18 was the biggest. It's always the first one. So maybe I'll change this up so that's not always the same. 40, 30, 20. So that function does that. Now, one other thing that your question on the coast got me thinking about is that the return statements are like, they like blow it up. They stop the execution of a function. A return statement makes it so that the function stops running at that point. It doesn't run anything else. So if you wrote print, they are the same right here. This will never run. It'll never run because there's a return statement ahead of it. It's valid code, but it'll never run. If you wanted it to run, then that would be an example of a logical error. You cannot have a statement after a return statement. Sometimes it's referred to as dead code. It won't run. There's other ways to create dead code. You could say, if x is greater than 7 or less than 7. No, I'm sorry. If x is not greater than 7 or less than 7, and then you put a bunch of code underneath that, then that would never run because x is always going to be either less than 7 or greater than 7. Well, greater than or equal to 7. So there's ways to create dead code, but they're almost all logical issues with your code. So this is a fruitful function, a function that we've written that returns a result. I'm going to put a comment in here. I haven't put a few comments in here. One is going to say, actually I'll put it above. So this is an example of dead code that will never run. Technically, you do not have to indent your comments because it doesn't even read them. It won't run because the return statement is above it. It's a hashtag, it's #. And so then I could write this function tests two numbers and returns the largest number. So that's a few functions, and then this could just be, these are a few tests of the function. All right, save that. All right. Okay. We're going to talk about a few things that are going to go a little bit out of order in the book. We didn't actually call anything incremental development yet, but this is really an example. Functions help you write code incrementally. So you can write a function, you know it works, and you know you need to do that logical operation inside of your code, You write that function, and you move on. You write another function for something else you need to do, then you chain everything together. That's what we refer to as incremental development. This concept called composition has to do with the fact that sometimes you can compose a particular idea in a few different ways. And we kind of demonstrated that with the two different styles of writing the else if logically produce the same result, but we were writing them differently. Okay, the things I want to talk about outside, this one goes a little bit far. I don't think, actually, I think we do get to 5. Anyway, whether or not we get to it, we're going to talk about we are going to get to it. Whether or not the book gets to it in this series, regardless, we're going to talk about it right now. And that is that we're going to change this code to work a little differently. Instead of typing in X and Y, wouldn't it be great if the user had to give us X and Y and we tested those numbers? That's more logical because we already know which one's bigger. We just type them in, right? Let's say we had the user gives us to that. So that's a function called raw input. So I'm going to say X is equal to raw underscore input, I think. Yep. Raw input, and then you could type the prompt. Like you could say, provide a number. And then Y is going to equal to raw input. Provide another number. And then to make it even more make more sense, we could say print the biggest number is and then we need to do string concatenation, which we talked about last week, is the plus sign. So now what this is going to do is it's going to ask the user, it's going to wait until the user enters a number, and then the user is going to enter another number, and then it's going to take those two numbers and feed them into the function, which is bigger.
After you have the bigger number is colon, what is that?
It's
the next two characters.
It's a space and then another quote, a quotation mark, and then a space and then a plus sign.
So,
I'm going to run this guy. And it says provide a number. So I'm going to say 5 and then 7. Now I'm actually going to get an error. No, didn't. I expected to get an error. Oh, I know why I didn't get an error. Okay, watch this. Okay, so I'm going to type in 10 and 2 and say, look, it says the biggest number is 2. Okay, let's think about it. Is 2 bigger than 10? No. Can anybody explain why 2 got made the bigger number? And this is the hint, that it's a string. Why would 2 be bigger than 10? Look at the operations that we tried to do. We compared whether it was greater than. I wonder if strings can be compared to be greater than or less than other strings. Yeah, they can. Actually, I mean, it's not true all the time, but in Python, that's definitely true. How do you think that it sorts strings?
ASCII code?
Yeah, well, it's an alphabetical order is the best way to say that. In alphabetical order, you know, we all know A, B, C, D, but by numbers, it sorts everything that's ones first, then twos, then three. Actually, it starts at 0. 0, 1, 2, 3. So 1, 0 alphabetically comes before 2, but not numerically. So there's a problem. All right. Anybody suggest something that we talked about last week? Can anybody suggest a way that we can change it so that it uses numbers instead of a string? We can change the data type. You may remember how we do that? We force it to be a different data type. We can make it a float. Anybody, what's the syntax for that? You know, we can't actually define variables in Python. So, what's the syntax for modifying a variable? We can't actually modify it in place. But do you remember there was a function for changing the data type into a float? Remember what that function was called?
I know we did. There's a specific function for changing the data type. Because I know we just did x equals float x.
Right.
And that.
Exactly. Yeah. So x equals float x. So now that you understand what a function is and how to create a function, you can see that this is a function. So as we just said, x equals float x would do it. And it will. And that's because this function takes an argument, it takes x, and what it does is it returns a floated version of that value. So it takes a string that needs to be a number, turns it into a number, and returns that value.
What, Doctor, I'm getting a little confused. Strings, we don't have any. So you're saying when we input 2 and 12, it was take the computer accept that as a string and not an integer?
That's right. Yeah, and I tried to show that right here using this print statement, is that it is a string. So you type string down in the text here. Maybe we need to make
Is
this.
that like the long, or is Python?
Well, the function raw input. Let me make this even bigger. The function raw input. If we were to go look at this, we might could. Let's see if it'll. Let's see if. Let's see if it'll. All right. So here is the description. Raw input. It takes a prompt. And it returns, what this character means, a string. So raw input always returns a string, so it's built in. So it takes a string from standard input. So that's what it does. Yeah. So the answer to your question is yes. That's what it does. It asks for you to input stuff. So we could mess our program up by saying 4 and 2. Okay, you can't convert 4 and 2. But if we ran it again, it's going to run. Sorry, 4, 2. The bigger number is 2. Oh, we forgot to float both numbers. Right? Let's try it again.
So you got rid of the float and XY that you typed in the numbers as string, put it reading?
Yeah, exactly right. My in data. Okay, so there was a question. Repeat the question again, because I messed
I
up.
kind of answered it as I thought about it. I'm good.
Yeah, so if we
Oh,
left
so
those
you-
as 4 and 2, they would sort alphabetically, but it would still work. So, so 2 would be bigger.
Comparing the number 4 to 2, it'd be comparing the string numbers that comprise FOUR versus TWO.
Right, the strings, the character strings. Yeah, exactly. So one more thing is that now I can't take a float and make it appear as a string. I need to turn it back into a string here. Okay. Now, this gets into another composition thing. It may be that we would want to put this code inside the function. And it probably depends on what the application was. Because right now, anytime we had some raw input and we wanted to use this function, we have to run it. So if we're always going to get the values from this function from raw input multiple times, we would probably want to move that into there. Move it into the function. Move this inside the function. And what that would do is it would make it convert it inside the function. And it would still return a number because it turned it into a number. So we'd still have to have this, but that's just personal style and whatever works best for the application.
Can you explain why you have to convert it back to a string to print out?
Because Python doesn't, the plus operator works differently on strings than numbers. So if I had the number 7 and I had another number 7 and I added them together, I get 14. But if I have a string, quote 7 quote, and a string quote 7 quote, and I concatenated them using the plus sign, I get 77. Okay? But here I have a string plus a number, and I have to tell that number that it's a string. So that's why I have to convert it back. Now it should run, and I get 7, 14. I get the bigger number as 14. All right. So that is, yeah, that's that. I think there was one other question that I wanted to, there was one other thing I wanted to say about it, but anyway, that, maybe I already said it, but that's that. There's all sorts of different ways we could actually write this. We could float them right as we gave them into the equation. We don't have to do it right there. So there's a few different stylistic changes we could do, but those all are equivalent. Okay. All right, I'm going to change this one more time. I'm going to save that, and then I'm going to say save as. Now that we've got it running, I'm going to save that as, I'm going to say this is 7. So here I talk about how I want to talk about looping here. Okay. I'm going to talk about 2 types of looping. We'll talk about a for statement more next week, but we're going to talk about a while statement really quick here before we continue. And a while statement is one way to do things over and over and over. And so, oops, I need to change this. Hold on for a second. I want to make sure that example 6 works for you, and I screwed it up, so I'm going to change it. There, now it'll work. Okay, so in 7, now we're going to do an example of a while statement. The The while statement will execute anything in a code block, and in Python that means an indented set of code. It will execute as long as a condition is true. Okay? So we could do something like this. While, and then we put a condition. And then we have a code block, and I'm going to format, indent this. I'm going to indent everything. And to start off, I'm just going to write while true. I'm going to take this type statement out of here because it's not really necessary. Okay. So now I'm going to execute this code, and we'll see what it does. So I'm going to provide a number. Oh, I just remembered what I was going to do. I'll come back to that. 4 and 7. Okay, the biggest number is 7. Now it's asking me to provide another number. 10 and 30. Biggest number is 30. 40 and 10. Biggest number is 40. It's just going to repeat this forever because this is true. That's what a while statement does. A while statement executes something until the statement is true. And since we're never changing the condition, there's no way for this to get updated. Okay? What is a way that we could stop the execution? What's that? Oh yeah, one way we could force the program to halt by just typing in letters. The program halts. Okay? I meant, what way could we change our program so that it runs a certain number of times?
Maybe a return statement or increment with a counter. You know, in your while loop.
Yeah, so this condition needs to equal false at some point for this to stop. And so on the codes they were saying we can modify that statement. So let's say stop equals start. We could say while stop equals false. So in other words, I created a new variable. I called it stop. And while it equals false, do this. Now stop doesn't actually exist yet, so I'm not even sure what's going to happen here. Yep, so stop's not defined. It won't even run. So I have to set stop equal to false. In computer programming, this is referred to as setting up the initial condition. So somewhere in here, if we set stop equal to true, it's going to stop doing it. So we could even type in stop equals true. It is case sensitive, by the way. So now this is only going to run once. It's going to come in here, and it's going to run this, and then stop's going to be equal to true. It's going to come back up here, and it's going to not execute it. I'll prove it real quick. Yeah.
Or won't it even run?
Yeah, it ran once. Why did it run once? I think is the question that you're asking. Is because this stop equals true is inside of the code block. So it doesn't change stop to true until it gets to this point. So it runs it once, then stop gets changed to true, and then it stops. Okay? So if we want to do something like have the user be able to say stop or keep going, we could take another raw input, like this. We could even provide some instructions. Enter Y to continue, maybe. I'm gonna make this bigger. All right, so the instructions I've told the user, I've said, do you want another set? Enter Y to continue. Okay, so how can I test wanna stop? I want to test wanna stop to see what it is. So let's think of an if statement that we could put in there that would allow us to test if wanna stop was equal to Y or if it was not equal to Y.
If stop equal to Y.
If stop, okay, is it equal or do I need two equals? Two equals to Y, then that's how I, notice I don't have to explicitly type the word then in Python. So the colon is kind of like, when I type the colon in an if statement, I say then. Then, stop's going to equal true. And actually, we don't really need to go any further, because if wanna stop does not equal Y, it's going to leave stop at false. So we don't need to explicitly say else stop equals false. That makes sense?
If wanna stop equals Y, then stop.
So if you want to stop, yes, I want to stop. Oh, I've asked the question wrong. You're right. You're right.
So,
You're right.
you
So,
got stop true. Right? If stop is equal to Y.
So if you ask, do you want to stop?
yes, I could do that. That would make more sense. Let's do that. That's better. Then we can leave everything else the same. I like that. It's less confusing, more elegant. All right, so wanna stop is equal to, if wanna stop, it means yes, I want to stop. That makes more sense. That's gonna be true, it won't go through. So now when I run it,
Shouldn't it say enter Y to stop then?
good. All right, all great suggestions. So now we say 5, 7, 7's bigger. I'm gonna say no. 8, 9, I'm gonna say yes. All right, so then it stops. So it enters more elegantly. All right. Okay. What I wanted to show is this thing called the try statement. A try statement will attempt to execute stuff in the code block. If it doesn't execute, it will run some other code. So here, I'm going to put this code inside of this try statement, and then the catch statement, and it returns actually an error. And I'm just going to print those aren't numbers. So now if I run this, does it catch? Sometimes I get my computer programming languages messed up. Try statement, Python. Sorry about that. Except, it's not catch. So that must be a different language. Okay. So try except. So if I say 1, 3, it says those aren't numbers. And then it says the biggest number is 3. So it's kind of like a warning. It's still running those through the process. Why does it still run? Well, because it tries to run these, it wasn't able to run, and so it printed that, and then it ran the function anyway, leaving them as strings. So maybe this could be more descriptive, saying defaulting to alpha order, something like that.
So what does the try accept exactly do? When you walk us through from the while to the accept?
Sure. All right. So the
Lost me too.
yeah. So the while statement says all this code is just going to be run and run and run until the wanna stop is equal to true, and that only happens if they say why, right? So we got the while statement. So the first thing that happens inside the while statement is we ask the user to provide a number. So they provide a number, and they provide another number. Okay? So what the try statement does is it tries to run everything in the code block. If there's an exception anywhere in the code block, it does not run the code block. Okay? So it takes X, it tries to convert it to a float. Normally, if I wrote 2 and tried to convert that into a float, I'd get red text on this screen over here, right? Okay. If I put text in Y, same thing, it's not going to run. Okay. What happens is it doesn't run this code. Instead, it runs the accept code. It's an exception. And it says, for us, it says those aren't numbers defaulting to alpha order. So what it's doing is it's printing that instead of running this code. And so those numbers are not converted to numbers. They're left as character strings. And so when they're passed later into our which is bigger, they're still strings. And we already found out that our function runs as strings. And then the result is just sorted alphabetically. And so it says the biggest number is 2, in this case it said 3, because O is before T alphabetically and H is before W alphabetically. So it's the last alphabetical number that shows up. Okay, so maybe you don't understand all the logic there, but let's just boil down to just what's happening in the try statement. The try statement tries to execute code, and if that code fails to run, in other words, if you have a runtime error, not a syntax error won't even run. If you have a runtime error in a try block, it doesn't execute any of the code in that try block. Instead, it executes code inside of an accept block. So that's it in a nutshell. And basically, it allows you to work around people. If you can anticipate the mistakes people will make, it will allow you to change your code up. We could do all sorts of things. We could, instead of just printing that out, we could, at this point in our accept statement, we could force them to go back up here in the code. Okay, we'd have to write some logic to do that. But we could say, those aren't numbers, give me some numbers again, and again, and again, and again. All right? We'd have to write logic to do that, but we could do that. And that's what a try except statement is useful for. Okay. The try statement, it tries the try clause, and if no exception occurs, the except clause is skipped. If an exception occurs, execution of the try clause, the rest of the clause is skipped. If the type matches the exception, named after the except keyword, well, don't worry about that. You can actually have different types of exceptions. Okay, but we'll get to that later if we even get to that. If you don't put anything, it'll just execute that. But you could say if it's a value error or if it's a different type of error, then we try to run it. Name error, runtime error, all sorts of different errors. Oh, and one more thing that I forgot to mention is that it doesn't always happen, but it may be the case that you, like let's say down here, well, I'll just do it. So this code won't actually run because it's expecting an indent. But let's say for some reason you wanted to leave this stub here. The proper way to do that is to use the keyword pass. What pass does is do nothing. So if you ever have a code block where you want to do nothing, the correct way to handle that is with pass. Pass says don't do anything inside of this code block. But you always, whenever you create a colon, you always have to create you always have to have a code block inside of that. So if you wanted to do nothing, you can write pass. You could just say x equal to 2 or dum equal to 2, something like that. The pass is more elegant.
Would pass throw you out of that function or move you on to the next condition within the, or not function or while statement, or will it just go on to the next condition in the while statement?
It just breaks you out of the if statement. So it's just this that it's finishing. Yeah, there is a way. Next week we're going to talk about for loops when we talk about looping, and there is a way to break out, and we'll talk about it when we talk about for loops. For loops allow you to loop over a series of numbers or a series of strings or a series of anything, but we haven't talked about series yet, although strings are series. But we'll talk about those next week. So it's 2:40, which is about the end of the 2-hour lecture portion of the course. So let's go ahead and take a break. We'll come back. We'll talk about the assignment because it's more than just following the book this time. But first, before we do that, does anybody have any questions? Any more questions? There's some very good questions today. I like lots of questions.
What if I don't know if you already covered this when I was a lost, but what if they entered a non-numerical input and you wanted to stop it and tell them they have to enter another?
Okay, yeah. Right, like you didn't want to do this. Then we could do something like that, like this. Number. There's other ways to do this, but I'm going to say number equals true. But beforehand, I'll write number error equals false. So this is just one way of doing it. I think this works pretty well. And then I could just say if number error equals false, then do all of this. Else print those are not numbers. Try again. I'm going to save this as 8 and then try to run it and see if it works. Now it did it, but it didn't actually execute this code. So I wonder why. Oh, it's because, I think it's because of this. Nope.
Because you put print in the quote instead of like a.
Thanks. That was it. Yep, okay. So now I can put numbers in and say, done. Okay, so that worked. So that was a good question, and that's one way to solve it. So basically what happens is that I create a variable that is false, and it's only changed to true if the except statement runs. If the except statement runs, I tell it not to do this. There's really no way around that because there's no except but else if inside the except. There's no else except. So that's the best way to logically do it that I can see. Any other questions? I think you were about to right now.
So what's a function object? The what uses that?
Right. Well, I showed you earlier that a function is a variable. Like a function is, so if I could print the type of which is bigger, and well, now I'm going to have to like 6, 7. So it's a type function. So a function is actually an object. Like it's a thing. An object is a data type that we haven't covered yet, that we'll cover later. But we're getting a little bit out of order. But a function itself is a thing. It's stored in memory, just like if you store 7 in memory. The function itself is stored in memory. We skipped over the part where we talked about recursion. If you're curious about it, you can read about it. But recursion kind of does a little bit better at proving that a function is an object or a function is a thing. But you can even do something like set something else equal to a function. And there's some interesting things you can do with that, but they're beyond what we really need to do in this course to program with GIS. But let's say you were going to build like something that modeled a person. Okay, like you wanted to build something that actually modeled a person, and so you could set something called hair color. You could set something called eye color. You could set something called height. Okay, but then you also wanted to model like growth. Well, you could create a function that would grow the person. So you could create a function and you could call that function grow. And so if you created a person, you could say person.grow 5, and that would change the height of that person 5 units, whether it's 5 inches or 5 meters or whatever. And so that function is stored as a part of that person object. It's just another entity of that object. So it gets a little bit further advanced than what we need to be, but it is, and that's why I kind of just brought it up, but didn't get into it too much, that a function is just another, we call them variables, but a broader term for the word variable is an object. It's a thing in the computer. And objects typically have properties and functions attached to them, whereas a variable is just usually a property, one single entity.
Oh, that makes a lot.
Okay.
And the way to look at it.
Okay. Good. All right.
One
But
quick question.
yeah.
Greg.
Sure.
That try except statement, can the try be used without the except, like as an equivalent to a do while? Could you say try this while this is true?
Like, provide an example.
Like in C++, we have while loops and do while loops. Like,
Okay.
That way it doesn't have to always be true. You know, it doesn't have to execute till it's false. You would say, do this condition while this is going on. Could you say that in Python by try this while this? There's no do while anything in Python.
Well, do while just means do this while this is true, right? So like it'd be kind of like you could say do this stuff while this is true, and then you wouldn't. So this is this stuff right here, and you could put this stuff up here, right?
Yes, sir.
Yeah, so, I mean, the equivalent is that you have to type it like this. So there's really not much difference between a do statement and a do while statement. In Python, you always have to put the condition up at the top. But if the condition is false to begin with, it will never run it. I guess that's the shortcut, is that in a do while statement, it will always do it once, right?
Right. Always do it once.
Yeah. Yeah, so the way that you have to make sure that it'll always do it once is to set up the precondition. Like we did. So,
Yes, sir.
yeah. All right, any other questions? Okay, so I'm gonna go ahead and break the conversation to make sure that we always have enough